My name is Bob Romero. I'm based in Dayton, Ohio. I'm a lead networking engineer for Citrix. A lot of people don't realize that Citrix is one of the leaders in networking technology. We're the 9th or 10th largest networking company in the world, doing over $1 billion of business every year. A lot of people are aware of our networking technologies from a perspective of VDI. So we have a product, the NetScaler or the Citrix ADC, that has a relatively interesting position in the marketplace in that it's a by definition a reverse proxy that can be consumed in a number of form factors from physical to virtual to container, which leads us into why the guy at Citrix is talking about microservices and Kubernetes and advanced architectures. And that's because that's part of our business segment. So we've had to, as SEs, Brian and I, and to kind of introduce Brian Holzer is based in Indianapolis. And Brian, why don't you tell them a little bit about yourself, and I'll swing into why we're talking about Kubernetes. Well, so Brian's based, he does the same thing I do. He's a networking SE for Citrix, covering more commercial, smaller type of business proposals and kind of a wider distribution of businesses. And so one of the reasons that we're talking about,
I'm back.
Oh, there you are. Go ahead and tell them.
Phone line dropped.
Yeah, go ahead and tell the people a little bit about yourself, my friend.
Sure. I'm Brian Holzer. I'm the local Citrix networking SE here in the Indy area. I've been here most of my adult life. I actually started out as an app developer many years ago, and worked my way through, wound up being a CIO and wound up teaching for Purdue for a while, and then, went to the dark side, went into the infrastructure. Been there for several years as a consultant, and now been with Citrix for a couple of years. So,
great.
And along the way, I actually met Josh's dad.
So one of the things that we've gone through in the last year was learning a lot about microservices. Many of our customers are moving to the cloud in a number of different form factors, whether it be traditional requalifying applications, refactoring applications for provisioning in AWS, or it could be requalifying and refactoring applications for microservices. And so there's a lot of mystique around not just the proxy infrastructure, but what the application delivery infrastructure looks like when you're talking about microservices. So we've put together a way or a methodology around understanding all the factors you need to control, or you need to be at least aware of when you're just deciding what the best proxy architecture for you is. So a couple things to start, and I'm relatively new to your organization. So we're going to talk a little bit about, high-level Kubernetes stuff. We're not going to spend a lot of time on this, and then we'll move forward. Also, I want this to be interactive. Feel free to raise your hand and ask questions as we go through the presentation. I don't want to be just preaching, one guy's verbiage to you guys. We're all professionals here. So a couple things to start with. We're going to go through from an agenda standpoint, some Kubernetes, just some nomenclature to understand what's there. The importance of choosing the right architecture, because there's quite a few different architectures. We're talking about scaling out a Kubernetes or a microservices-based application. Who are the varying stakeholders of import that we need to make sure that when we make these decisions, we know who they're going to affect, what all the options are, and a deep dive into what we call the 7 attributes for what we're going to talk about, the 4 largest considerations from a design option perspective. All right, so jumping into the Kubernetes portion of it, it's important to understand what a pod is. A pod is the essential, we'll call it data point in your Kubernetes architecture. The pod can contain a single container, but it can have many. It uses local addressing, it requires CNI, and it allows us to communicate with other portions of an application or other pods, leveraging overlay networks like Flannel and Calico or Canal or Weave. Okay, so the pod is the smallest instantiation. It can contain a single container, or it can contain many containers that need to work together. Okay, we're going to talk a little bit about the clustering IP addressing. The cluster IP addressing is how the application is going to communicate within the services architecture, okay, versus outside of it. And then we're going to talk about the service types from a perspective of addressing whether we're talking load balancing, node point, or the standard cluster addressing. Do we have a fairly clear understanding of what these things are? Do we need to go any deeper into this for this conversation? All pretty straightforward starting points.
Yeah, and don't hesitate to speak up. I mean, everybody is got full ability to mute and unmute themselves. If you got a question for the speakers, I assume that they're game to answer them.
Absolutely.
Yeah, I guess maybe for a little bit of our background, from the audience, what's the percentage or how many folks are working in microservices architecture or are starting to discover these technologies at your current opportunity, your current employment? I'm going to take that as not a lot.
Yeah.
Okay. So let me go ahead and ask the people on the phone, what do we know about layer 7 versus layer 4 load balancing? Because this is going to be kind of a key point in how we proceed forward from designing an architecture for microservices environment. Not a lot. All right. There's some unique and distinct differences that need to be understood. Layer 4 load balancing is largely based on address and port only. It's very simple. It's like the elastic load balancer. It's relatively straightforward. You don't have the ability to do things based on layer 7 context or on the payload type. So we can't ascertain differences in where it was source originated, what the operating system is, agent ID. There's just a lot of things at layer 7 that are available to us to use for switching, for load balancing, and for the ability to take advantage of the protocol in itself. In layer 4, it's going to bind to a layer 7 protocol, or it's blind to the layer 7 protocol. It can't necessarily see the difference between HTTP and HTTPS. So when you're doing things like marking headers in an application, the layer 4 load balancer is not going to see the headers for HTTP or HTTPS, where we can make those changes with a layer 7 load balancer or a layer 7 application delivery controller. Okay. Now, when I'm speaking about this stuff, I'm speaking vendor neutral, because a lot of these concepts are just are spread across all the different types of vendors. And it's really important to understand that from the load balancer or the reverse proxy perspective, there's a lot of different types of solutions out there. When we're talking about Kubernetes or microservices, we're going to talk different vendors than if we're talking traditional. So in the Kubernetes environment, some of the vendors you'll see will be like Nginx or HA Proxy, of course Citrix, Avi, just to name a few. Where in a more traditional or physical instantiation, we're talking a 10, F5, Citrix, of course, as another type of enterprise grade layer 7 load balancer. So to take advantage of being able to support things like advanced context and advanced manipulation of a flow. So in layer 4, there's no ability to do that kind of stuff. But in a layer 7 load balancer, I can do anything to the header or the body of the application in flight. Also, we can unravel and do SSL offloading in a layer 7 load balancer and see the context of the application and start to do security remediations as well. All these things are available inside of the microservices environment as well. So when you're talking about how do we secure application calls from one container service to another, we're going to leverage a layer 7 load balancer to kind of remediate what those security parameters are. When we talk about things like persistence, so as we scale an application out, it's very limited in layer 4. In layer 7, we can pretty much write a rule dynamically and set persistence with, you know, whether it's cookies or whether it's based on IP or whether it's any number of things. It's completely customizable. And then with a layer 4 load balancer, things like security are very limited. So you can just see port visibility and you can see the IP address, but it lacks the ability to do deep packet inspection. And that's what you really get with a layer 7 load balancer. So there's a huge amount of differences and facility available when you're talking about the actual solution, much less how we choose for an architecture. Now, there's some importances that we need to know from the microservice perspective. A lot of companies are struggling right now trying to understand where they want to get to. So there's a lot of chatter that we're running into in terms of full mesh architecture. That sounds like a good thing. That sounds like something that's going to allow me to scale across multiple clouds and whatnot. Well, you know, there's a balance when you're talking about architecture between complexity versus what's supportable. And so that's where Citrix has kind of looked at all of these architectures and tried to figure out all the different parts that make things more important. Okay, how do we choose that we can support this type of an architecture? So one of the things that we're trying to understand is the changes inherent to the culture of the IT department. So, you know, is your company ready? Does it have a team that's able to handle these types of changes with a much more dynamic architecture? Is your platform team, the networking team, got the skill set to understand these new divides? Because we're building this infrastructure in a completely different way. You know, we're using CI/CD, we're using Spinnaker, Jenkins, as we're displaying code, and we're building things in a much more dynamic kind of perspective. Also, there's this whole concept of north and south versus east and west. So in a north and south, we're going to be looking at the traffic as we enter the microservices environment. And east and west, we're going to be looking at how the microservices interact within it themselves. So there's a lot of trade-offs that we want to understand as we're making these decisions on the benefits versus complexity. Rough morning. And then of course, there's the rapid pace of open source innovation. You know, we were hearing rumblings of Istio a year ago, and now it's here with the latest version of Red Hat. So that wasn't really even a thing. This time last year, there was a lot of chatter around canary deployments, where automated deployment of new source code was then tested and either rolled into full production or rolled back, all based on error count of the quality fit. So all of these things can play into it from a feature perspective for your application. It plays into uptime, and it plays into the ability to train your people to manage it. So we've identified a few stakeholders that are pretty good starting point for most organizations. There's been this whole understanding around, well, what's DevOps and how does DevOps play into the role? But the DevOps team is really much more around deployment cycles and faster release for the application, where there's that whole other group, the NetOps team, that's kind of been there for a long time, supporting the applications. And so they're looking at network monitoring and uptime and managing those SLAs for how the application is consumed by the business. All these other teams have different types of responsibilities, whether you're talking about the SRE who's looking at observability and postmortems versus DevSecOps or standard developers that are just trying to do user experience and make sure the application's working, make sure discovery and routing are working. And so now that we have all these different groups, what are we going to do from a perspective of giving better opportunities for architecture in the environment? So that's where we come into the four main choices that we've seen most of our customers either actively pursuing or discussing in a deeper level, okay? We're going to go through these and put the kind of decision process that we've shared with our customers and that we've also learned more about from our customers. But by and large, we see customers adopting the two-tier Ingress model primarily. It's out of the gate. It's much simpler to leverage. And it generally speaking, all of the pieces, parts are there when you're talking about out-of-the-box Kubernetes or microservices templates, okay? Unified Ingress is the second tier that we're seeing because of the way the Kubernetes can be packaged by some of the other vendors. Then we're seeing full service mesh as the next adopted conversation. Now that's the one that takes the most complexity and has the longest runway for deployment, but seems to have the biggest amount of payoff. By the same token, it takes the highest talent in the staff to be able to manage, the complexity that's been added. So the way we look at it, we break it out to 7 key attributes to evaluate the individual architecture options that we've been seeing most customers talk about. And so I've alluded to it, but skill set. I see skill set when you're talking about a Kubernetes infrastructure. I can't be emphasized that a lot of traditional IT departments just don't have the skill sets to stand this up right now. It's something people are learning, but not necessarily everybody's doing. I know of 3 or 4 large environments in the Columbus area that are deploying at scale across the country. I know about the same amount in Indianapolis, a few more in Louisville. We're just not seeing huge amounts of companies deploying at this rate, although we see a very large percentage of our customers having some sort of long-term goal for this type of deployment. So skill set is one that we're seeing people really invest in. Security, well, understanding new technologies always brings to the app security conversation. Observability. Observability is a key term that we were looking at analytics a month ago, now it's observability, but largely understanding what's going on in the environment and then choosing the components for your infrastructure really play into what you can get back from an observability standpoint. And by observability, we're not just talking, is the application up or down? We're talking how many connections, how's SSL being negotiated? Are we being compromised? Are there attacks on the application? It's far more than uptime. It's all the intrinsic granular details on how an application is performing in any one environment, okay? And then of course, CI/CD, how are we gonna handle CI/CD for these environments? Scale and performance, what tools, and then are we gonna use a unified control plane like Istio? And there's several others that are in the pipeline that I see coming. Istio was the first big one of import that really hit. Brian, were you gonna say something?
No, that's just concurred with what you said.
Okay, awesome. Any questions to this point of where we came up with these attributes or how we got to this point?
Actually, a quick question. On the previous slide, you had the different styles of deployment, and they mentioned kind of Citrix-specific technologies there, like the NetScaler, and I don't know what the CPX bit is. Are there open source equivalents to those things?
Absolutely, absolutely. And I'll be talking to them as we talk about
Okay,
the individual tiers.
perfect.
So yeah, for
And
sure.
and I want to point out that Bob mentioned that these are 4 service models that we typically see. It's not that there aren't others and variations in between, but these are the 4 typical ones we run across. Just want to reiterate that you may see others that are variations between these, or or we even way out there. So.
Yeah, and that's a really good point, Brian. I don't think a lot of people realize how much we're having these conversations, how many folks are really trying to invest in them. But, large organizations who have public-facing applications are looking for ways to dynamically scale and, be more available to customers, but lower the overall cost. Because once you build this stuff out in the cloud, if it's always running, it's that old paradigm, nobody wants to build the church for Easter Sunday anymore. We're going to build a dynamic application that's going to scale, and that's going to give us all the extra constraints and information to make it more profitable and a better user experience for customers. So into the first one, the 2-tier Ingress. I'm going to kind of build this guy out because there's all 7 of those attributes are kind of dictated. Then we'll go to this. Now, if you notice, we've just gone ahead and put the Citrix ADC as the ingress. That can literally be any layer 7 load balancer, okay? It could be an F5, it could be an A10. I work for Citrix, so all my slides have my products in them. But open source equivalents for things like a CPX would be HA Proxy, okay, or Nginx. I don't know of any traditional enterprise grade 2-tier or that external ADC. I'm sure there's something out there. You could probably use HA Proxy or Nginx as a container in the front. But literally, what this is going to do is it sits outside the cluster. You're managing that north to south inside the cluster. Chances are this is going to be an Nginx or an HA proxy inside the cluster, and we're going to talk node port for all the applications. In this model, we have the ability to also communicate with an Ingress controller that talks directly to Kubernetes QAPI, the API controller, so that we can get some kind of understanding of what's going on from the inside. But a traditional, the open source equivalents may or may not have that ability. So you have to vary, your mileage may vary as you pick your own adventure. But from that perspective, this is relatively limited in observability, especially when you're talking about using Proxy or some of the open source equivalents, mainly on the inside. Okay, if you're using a more enterprise grade on the front, you'll be able to get some sort of telemetry and observability on that application traffic as it enters. But everything inside is relatively dynamic. So scale out and performance are pretty good. The amount of tools and support when you're leveraging Proxy, which is the built-in proxy, are going to be somewhat limited. And that's what we get out of it. It's open source, it's available, it works great, but it doesn't have all the bells and whistles that we see a lot of people leveraging. This is usually the entrance into a Kubernetes application. We see these in a lot of lab deployments. We see these in limited application for a first tier shot at it, for a scalable application. Depends on the amount of users and depends on the business priority. But pretty straightforward. We see a lot of this. This is probably 60 to 70% of initial Kubernetes deployments in most of my customers. Now, when we have a network savvy platform team that can start to understand a little bit more about what they want to get from a layer 7, we can go ahead and tie the ADC on the outside as the entire plane and load balance to all the different node port associations or the different applications. We start to get more telemetry, but it's still very limited. There are still limitations on CI/CD based on what we can do with Kube Proxy, but we're able to talk to the Kube API controller. And then, of course, layer 7 stuff is still limited on the east to west traffic because we're leveraging Kube Proxy layer 4 controller. Doesn't have the ability to do a lot of extra things, and is steel enabled. Unified Ingress, haven't seen a lot of it, but I've seen a lot of people debate on unified Ingress, getting that higher level layer 7 load balancer on the front end and load balance all the way to the back end to the node ports. Makes it a simplified deployment, but not seeing as many of these going in as possible versus the more unified 2-tier. We're seeing a lot of the 2-tier. Any questions on simple unified ingress?
What's a CIC?
Okay, so the CIC is the Citrix Ingress controller. So we have another container that sits inside the environment that can then proxy commands directly to the NetScaler for the Kubernetes environment. So when Kube API sees that you've gone over a threshold and you need more containers to support an application, it builds new containers and adds them to the application. CIC gets the information from Kube API and then provisions the load balancer to add those to the back end of the load balancing service. There's tons of different types of ingress controllers depending on the platform. This is the one that we offer for free with our solution. Does that answer your question?
Yep.
Okay.
Sorry, I have one more question.
Sure.
So in either of these, unified or split out ingresses, 2-tier ingresses, what a lot of ingress controllers will just spin up like ALBs, right? So are you responsible for maintaining the high availability of a Citrix ADC in the cloud?
Okay, so on this front tier, you're asking if the CIC maintains the HA for the front tier?
No, I'm asking what you have to do to maintain HA. Let's say you're running these Citrix ADCs in AWS, right? What do you have to do to maintain high availability of these Citrix ADCs themselves?
Okay, that's kind of a long question for today. Greg, can I circle back around? I have a ton of information on that one.
Sure.
I'll make sure and get your email and reach out and give you a call. If you're not aware, and sadly GitHub's down, we do have a GitHub environment at Citrix. And once you get into github.com/Citrix, you can just search AWS. We have tons and tons and tons of templates for deploying HA across availability zones, one interface, two interface, three interface sets, all types of stuff. Generally, we stick a load balancer, a layer 4 load balancer in front of it. And then when the HA function happens, as the NIC moves, there's some sort of a delay. That's kind of inherent to most of these load balancers sitting in AWS. An option to maintain a higher kind of failover rate would be using GSLB, so global server load balancing, which is based on DNS, and that's built into the ADC. That's a free function. But I have some more content, and I'll go ahead and get that over to you, Greg. Okay?
Yep.
All right. Any other questions while I'm here? All right, cool. So service mesh, this is the big bad boy that we see the most chatter about lately, and that's talking more about Istio. And what you'll notice that's completely different in this environment is this whole add-on of sidecar. So essentially a containerized load balancer for every single pod, okay? Where that mesh happens between the sidecars, all right? Now, depending on how you build it out, this can be built out with Citrix CPX as the sidecar, HA Proxy as the sidecar, Nginx as the sidecar. You're not really limited to that. You are limited to what types of traffic the sidecar will see depending on the solution that you choose. So in some of the more notable open source ADCs or container load balancers, you'll see that there's a limitation of things like consumption of the APIs or of observability. If you're using Citrix, you're using Navi, you might get a higher level of observability and higher consumption of API calls per feature. Essentially, this is the thing that's going to let you manage the sidecars by the platform team and segregate the load balancing to the network or security team, because the entire environment inside of the container environment is typically managed by the platform team. And then it's just a snap-on to the network. And so you'll see typical, well, not really typical, but you'll see that Citrix ADC layer on the front end of the service mesh load balance across multiple clusters if you need to. That mesh can also extend across multiple clusters in multiple domains. So it's literally being able to scale the application and its environment across, you know, in an AWS constraint, multiple availability zones in multiple regions, all being the same application. But that mesh is all happening between the sidecars. So what you end up is a lot of complexity, okay? There is support for the Istio APIs, but you know, that control plane is segregated or spread across multiple availability zones in multiple regions, or spread to, you know, on-prem or colo or wherever else the application exists. As far as continuous deployment, it's great. It's the way to go for being able to extend your application. Whether you're using Spinnaker and you're using Canary build through that, or you're using anything else, quite frankly, it's a great snap-on. The big downside of full service mesh is it's a relatively steep learning curve to explore Istio. That at Istio is not small. I had to provision just for my lab 32 gigs of RAM and 8 vCPU just to stand up a small test instance. So it's there's some investment to this. And then the last one, this is one that's more our secret sauce. I'm not going to spend a lot of time on this, and this is Service Mesh Lite. So you'll notice in the previous slide where there were sidecars, let me get back to that, sidecars for every single pod. With Service Mesh Lite, we have the ability, because we can make this, this container, the CPX, really, really big. So our product has the ability to go 9 cores and 64 gigs of RAM as a container. Typically, we think of containers as smaller applications, not necessarily the case. What we can do is be that kind of, you want to call it hairpin connection between all of the different pods or all the different applications. So from that perspective, you lower the amount of containers associated with the sidecars to a single one in the environment or cluster, and then control the application conversations in and out. And so things like SSL between the applications or application firewall between calls of the applications. Say, for example, it's an EMR system and you're, you know, looking at billing versus general ledger. It's nice to be able to stand up application firewall calls in between those two components of the larger application. So this is the one that we've seen a lot of chatter about because it's kind of based on our ability to size a container very large. However, I don't have any customers that have deployed this in a production environment yet. Right now, it's the full service mesh we're seeing a lot of, and the very first one, the two-tier ingress. Any questions on service mesh light? Okay. So the big thing, just to roll back up the four main architectures that we're seeing the most of: two-tier ingress, unified ingress, service mesh light, and service mesh. And it's the opposite ends of the spectrum. We're seeing the most amount of conversation around the two-tier ingress and the service mesh. Little blurb. It really does matter when you're looking at cloud native solutions. You know, there's a lot of really great open source tools out there. I use Nginx and I use HA Proxy in my own development daily. Great solutions, but they don't necessarily give every enterprise the ability to get the observability that you need to, you know, make sure you can adhere to your ELAs, make sure that everything's working appropriately. You know, it's hard to tell if a user's having problems, what type of browser he's using unless you have the right tools in place. So, you know, whatever you choose for your architecture, try to choose the right solutions that have all the features you need to be able to operationalize it in an appropriate fashion. Some of the broadest open source tools that we've been working with a lot, you know, of course, Prometheus and Grafana from an observability standpoint, the ability to, you know, record data in timely fashion, report on it. A lot of Spinnaker, we've been doing demos with Spinnaker lately on Canary deployment using Kayenta. Of course, Istio, large focus of this conversation. And then, you know, I don't know if you realize, we're highly partnered with Pivotal Cloud Foundry and with Red Hat as platinum partners. So in terms of Kubernetes platforms, those are two great ones to take a look at. Also, we work in Google, we work in Amazon, we work in Azure from a perspective of the Citrix availability. So all that's out there. Just the last thing is performance versus scale. I think what you're going to see as you build out your applications, leveraging your open source tools, there are some really good solutions in the enterprise side of things that give you a little more performance, maybe a little faster, a little lower latency. Every single hop that you have in your application, that latency compounds. And so having really good, fast, assurant solutions will make your application perform much better. From an observability standpoint, holistically, we're looking at a lot of different types of metrics. Whether it's, you know, log metrics on the application calls, or tracing metrics. Zipkins become really, really important to microservices teams to understand tracing of the applications so that they know how the calls are pathing. And then service graph to know the availability of the application, where are there errors in terms of how that application is processing. So service graph is a free tool that comes with the ADC if you're leveraging a Citrix solution. We give this for free. We allow you to see all types of interactions within the mesh in a real-time basis. And so just one last little blurb of what we're able to do. I think that's pretty much my presentation. And I hope this has been interesting. Thank you very much.
Yeah, thank you all for being here. Thanks, Bob and Brian. Everyone is virtually applauding right now. Are there any questions for Bob or Brian right now? Actually, if you go back one slide, where do I get my hot drinks?
I don't see it.
You got front-end hot drinks. You had MySQL Fruit. I was quickly parsing your diagram there.
Oh, yeah.
Yeah.
So hot drink, cold drink is one of our test applications. It's a kind of a built-in store that we deploy and we break and we show people, you know, if we're doing cert-based auth from application to application, you know, here we'll take the line of cert out of the YAML file and it'll break the application kind of thing. So yeah, it's just one of our test applications we use to demo the solution.
And there was a question about the recording quality, and it should have solid audio. So John had asked about the recording. Some people said it's been cutting out. It'll definitely be available on YouTube in probably the next couple of days. And it should have, we've had really good luck recording on the cloud for Zoom. And I know it was solid for me, so I didn't have any problems. I had a quick question on the complexity scale. I mean, you showed the multi-tiered, the two-tier, and then unified, and then kind of up into the mesh ones, and talking about performance and latency. I mean, it seemed like the reducing as many moving pieces as possible is beneficial, but is the downside that you remove some of that observability? Is that why people would not go with a straight, like unified, you know, one ADC with pods?
Yeah.
Typically,
That's a lot of it.
well,
Go ahead.
it's that, but it's also, you know, if you just have the straight one ADC with the pods, you don't necessarily have the ability to see or control that interaction between the pods. Does that make sense?
Yeah. So you're really relying just on the internal Kubernetes networking for
Yeah.
that. But
You're using Proxy to do it, which is, you know, it's layer 4. It doesn't have the intelligence at layer 7 that we bring to the table, or using an ADC brings to the table.
I guess I've never deployed an application yet where I needed that much intelligence inside the cluster.
So I've got,
The complexity thing. The Istio guys basically started with a microservices model for everything that comprises Istio. So that would be, you know, Galley and Pilot and Mixer and all of those things, right? With Istio 1.5, they pretty much collapsed all of that back into a monolith. Is that something that you guys are going to do as well?
so yes and no. With Istio 1.5, we're already pretty much ready for it. A lot of what we're looking at from a 1.5 standpoint is going to, within the Istio framework, going to a more service mesh light. It lowers the complexity, but allows for that Istio integration across, you know, multiple environments. So we've kind of gone to lower the complexity within each of the clusters and leverage all the things Istio is really good at stretching the environment. If that answers your question.
I think so.
I'm a little bit confused. It sounds like you're saying Citrix CPX includes Istio. What's the
It's very
interaction?
similar. I was just curious because the Istio team basically admitted that microservices in their case was pretty much a mistake. I'm sure you've played around with Istio. It's very complicated to get everything up and running, and there's a lot of moving parts. So them switching from microservices to monolith with their 1.5 release is seen by many as like a really positive thing to them.
Yeah, it'll be interesting. I mean, Google just announced their version of Istio, what, 3 months ago? It'll be really interesting to see how that all plays out. The microservices backend for the application is really more about how are we scaling the application, how are we dynamically building it, how are we doing CI/CD in a way that, you know, we don't necessarily have to have our fingers in the application every single moment. We want to be able to scale it and take advantage of, you know, all the advantages the cloud brings. You know, Netflix really changed the game for businesses from a microservices standpoint when, you know, they were able to build out such a compelling argument on, well, we're going to always have our application available. We're never going to reboot it. We're never going to take maintenance. We're just going to build this CI/CD attribute or function into Spinnaker so that we can do canary deployment and validate that in real time as we're deploying, we're keeping things live. that really changed the game for what you could do and what you could get away with. So now people are just, they go to Netflix and they click on the button for their movie and they see the spinning thing. They don't realize that kicked off a bunch of scripts and generated some containers and is, adding configuration to the networking and load balancing, also that they can watch that one movie. I think we're going to just see more and more growth in this segment. But yeah, I think the first iterations are by far more complex than what we're going to see the long-term solutions being. And Istio is a perfect example of they looked at it from one view and now they're rethinking it.